Hello guys, this video will instruct you guys to do the simple random sampling from a population. So for this videos we will use the EAI dataset to just demonstrate for all the data analysis structure we will do. So first of all we can see this will be the population data. Okay. So if you have already read in through for the examples of the EAI example, okay, so they demonstrate about this could be the information about the information of the annual salaries and their whether or not the managers had already get in the training program of the company or not, and the sample includes about 2,500 in total of all the manager of the company, if that's possible for us to collect the data. And at the same time, I will try to generate for a data set that should be a sample of 30 manager only. And in the same time, I will going to generate for the sample of not just 30 managers, but like 100 manager for benchmarking, so to see like is there any difference between if you really gonna do the data collection for not just 30 but like 100 measure, and if we see like any different. So we're going to do it with the same thing, right? We collected the same thing, the same data, okay, and we're going to do it. So now let's go and check it. So the reason is that we will have to select for a really random symbols sample. So we will going to do it by just select everything by a kind of very simple philosophy. We use a function called random, and random function we try to generate for a random number between 0 and 1, and you when you put it on they just kind of like simplify, manage and simplify, just reorganize everything into the random order. And the reason why, the fact is like I cannot select the data like for the first 30 guy from here to here. They look very simple, right? They look very convenient, but it's not the real way for us to generate for a random sample, because they're not really random. You pick from the first into the 30 manager of the company, and they maybe have the set of the same characteristic like geographical, like demographic, and other kinds of characteristic of this manager that's maybe very close to each other, and they very close and similar to each other, so they're not really random. And at the same time we cannot do it like we for example we collect the data of the first guy, the second like this way, and then I random pick another third guy, and then I do it the same and the same. That takes too much time, and the very simple way will be we will use the random variable. So how can we do it? I will just demonstrate for you. So over here I use random, okay, and it will return a number. As I say, that will be a random number between 0 and 1, and I do it the same. I click on and says order. I just copy all the function, and you can see like over here all the data has just generate for a random number, and I will put them into this could be called the ranking, okay, this could be called the ranking. And you see like even all the time I jump like that, I make any kind of function or execution of a function, so the ranking and the random number just generate like pop up rapidly. So in this way I can select the data, and I go into data and I sort it, right? I will sort the data based on the ranking from smallest to largest. And you see over here now all the managers, they have been just kind of like flip it up, and some of them just pop up kind of very randomly. Like now the first manager, they actually the 675 manager before, and now I just select for my the first like 30 observation, the 30 manager, Actually it jumped to 31, but remember we have the label of the data, so this will be 30 manager. Okay, and the same way we can select for the first 100 managers. Okay, this is the data of the 100 manager over here, and I generate the same way. Okay, and you can see it. Yeah, yep, they has been generated randomly. Okay, now let's go and just check it for the, you already learned about how you can generate for a simple random sampling, right? Now we will go in to just compare about the performance of the sample and how they perform compared to the real data. The real data mean I'm here, this will be the population. Okay, I will compare the population number. Maybe I will generate it later. This could be the sample of 30, and this will be the sample of 100, and we're going to see like how they are different or not, and if they're the same. So I'm going to just demonstrate about the difference in some of the criteria like the mean value, okay, or average. Another one could be standard deviation. Okay, another will be the proportion of completion, and the last one that will be the standard error. Okay, now let's go and generate for the something like that. So first of all, I'm going to generate it for the population, the whole population, and with this one for like the benchmark. Okay, for the benchmarking, and I will put them the number like the right one. Okay, so the mean values I will use the average function for this one from B2 into P2501, and I click on, and that would be okay. I will just try to reduce the dimension and put on like this way. I'm sorry. Okay, so that will be 51,800. That will be the mean. That will be the mean salaries up from the population. Okay, and this could be the very true values of the mean, the average salary of all the you think about like all the manager that this company have. But however, with the limitation of the time and the reason that we just want to generate for the result from this the sample of 30 manager, let's go and check it if they have any kind of different. I will also use the same average function, and I'm going now to check from X2 into X31, and this will be the 30 manager of this sample. Okay, and we see, you can see over here. Okay, that's 52,567. So it a little bit different, right? It a little bit different compared to the original population mean, about like 767, and this difference is around like just now. Let's check it. Just 1.48% different. So you see, like in case I cannot collect all the data from the whole population of 2,500 manager, right? And in case like in the future when you have even larger and larger population of up to 10,000, 100,000, or even million observation, in that way, even when I just collect the data from the 30 observation of the sample, they still very close to the population mean. Okay, and the same way I'm checking with my sample of 100 observation from N2 into and 100 and 0 and 1. Okay, and let's check it. Now man, let's just do it very cool. And now, wow, even they closer, they just different about like 54 54 unit from the real values of the population mean, and that must be very small number of the difference. So yeah, it's about like just 0.1%, very close. Okay, so even with the sample of 100 observation, they even closer and they even better. Okay, and now let's check for the standard deviation. Let's check for the standard deviation generated from the population, and I will choose the HDD, right? EVs. However, remember about this one, I will have to point P, because this is the standard deviation of the population. The P will stand for population. Okay, and now let's check it and do it with the annual salary from B2 into B 2501. Okay, last could be 3999. Okay, let's check it if we are very close to that with the sample. Okay, so with the sample we also use the same STDEV, but now remember this is just a sample of 30 manager that had been derived from the population of 2500 manager. So we just point X stand for sample. Okay, and let's go and do it with the annual salaries of the 30 manager, and that should be 3481. That's in some way not too bad, right? It's still very close to the around 4000 of this one. Let's check with another one. A standard deviation of the sample of 100 observation. SGDEV.S and 2 into and 101. Okay, that will be 3723. Okay, so in any way like they very close to the 3999, and that's cool, man. So basically based on them two, we can say like we can conclude like the sample perform pretty well. Okay, compared to the real population data. So in case like we use the sample, that we can save a lot of money, time and effort, but we still get quite a good and acceptable result of analysis compared to if we really spend time, money and effort to collect all the data of the population. And now let's do it with the proportion of completion. So proportion of completion will be the counts of the people who has already say yes in the training program, right? They have if they really has finished the training, so they will say yes. But if they have not get attend in the training program of the companies, they will say no. And let's gonna check it. So first of all, we use the function count if you already learn it to just formulate C2 into C2501, and let's check it if they really have the answer yes. Okay, over here, and you say I will just click on. So you see over 2500, 1500 has say yes in the population. So that means in the total of 2500 manager, so around 1500 of them has already get in the training program. And let's check it how many percent of them in total. So that we divide for 2500, so that means equal to 1500 divided for 2500. That's the total number of all the manager, and that means that's equal to a percentage of 60% of all the manager of the company. In terms that we collect the data from the population, so they already finished the training program. And let's go and check it if how did they do with the sample of 30. And in case like the people ask how many percent of you has already finished the training program, and I don't have enough the data, I just have the sample of 30. And let's check it. So the same way I use the count right, I collect from training program and I say yes. Okay, and that should be 20. Divide for, and here I have a 30 in total, so it's about pretty good. It's around 66.7% from the sample of 30. We say like, yeah, the proportion of the completion about 66.70%. They pretty close to the 60%. It's not bad. Okay, and the same way we can do it and check it for the sample of 100 measure, and to see like if they finish it or not. Okay, alright, and this is 60. Oh man, so 60 we divide for 100 guy, right? In this sample of 100 manager, so they actually come out with the 60%, and they're very close to the population proportion. So one more time I can reinforce about my idea about that. The sample perform pretty well, okay, compared to the real population data. And let's check it for one more thing. When the people talk about another option will be the point estimation and the standard errors of the mean. So standard error we equal, over here we will just focus on the infinite population, and this will be the function. Okay, we will take the standard deviation divide for the square of the sample mean. Okay, the sample size. So of course they will not present for the population, where they just present for the sample of the 30 and the 100. And let's go and check it. So how can we do it? We go and check it by use the remember with the standard error. Okay, the standard error will be the standard deviation divide for the square root of the sample size. Okay, the sample size over here may be sample size. Okay, the sample size over here will be 30 observation. This will be 100 observation. And now let's check it for the standard errors. Let's just do it with the standard deviation divide for sqrt. Okay, of the sample size, the square root of the sample size. Okay, and let's check it. That should be 635.6. This should be the sample standard errors of the sample of 30. But I'm pretty sure if you use this with the same function, and we use this for check for the standard errors coming from the sample size 100, they will be smaller. So that means this will be very close to the theory that we already talking about in this section about the central limit theorem. In this, what would people say like the sample distribution of the sample mean can approximate a normal distribution as the sample size become larger. And that mean what exactly this means? The sample size become larger, for example, from 30 into 100. The distribution of the average become normal and narrower. So you see, for example, here the people just use the sample of 5 different animals, right, for their weight, and you see this could be the distribution of them. They quite a steep and they broaden. But however, when the sample size become larger and larger with more the animal and you got the weights of them, their distribution curve become more and more narrower. And with the very big sample size, they become a normal distribution and they very narrow. Okay, so this could be what the people say called the larger sample size, the closer the data will be normal and narrower. Okay, alright, and this will be demonstration of the sample, the simple sampling and how they compare for the performance of the different sample.